Welcome to the presentation on serverless architecture design. Today we will explore the fundamentals of serverless architecture, focusing on popular cloud platforms AWS Lambda, Azure Functions, and Google Cloud Functions. Let's dive in. Serverless architecture abstracts away server management, allowing developers to focus entirely on writing code. Instead of provisioning and maintaining servers, developers deploy functions that are automatically triggered by events. The cloud provider handles everything related to infrastructure, scaling, and availability. Serverless architecture offers several key benefits. First, scalability. It automatically scales based on demand. Second, cost efficiency. You only pay for the compute time your function uses, making it very cost efficient. Third, it reduces overhead by removing the need to manage servers. And finally, it accelerates time to market, allowing developers to focus on the business logic rather than infrastructure. Despite its advantages, serverless has some limitations. Cold starts introduce latency when functions are ideal. There's also the risk of vendor lock-ins, as you might become dependent on specific features of your cloud provider. Additionally, debugging and monitoring can be more complex due to the stateless nature of serverless systems. Let's start with AWS Lambda. It's Amazon serverless compute service that lets you run code in response to events. You can use it with languages such as Node.js, Python, Java, Go, and C Sharp. Lambda automatically scales and manages the underlying infrastructure for you. The core components of AWS Lambda include Lambda functions, which are executable units that respond to events. The API gateway helps in creating REST APIs to invoke Lambda functions. IAM rules manage the permissions, and the AWS SDK lets Lambda interact with other AWS services like DynamoDB or S3. Pricing for AWS Lambda is based on the number of requests your function receives and the execution time. You only pay for the time your function runs, making it a cost effective solution for many use cases. Now let's look at Azure Functions. This is Microsoft's serverless offering that allows you to execute code in response to events or HTTP requests. Like AWS Lambda, it supports multiple programming languages including C Sharp, Python, and JavaScript. Azure Functions consists of function apps, which are containers for your functions, bindings that connect your functions to external services like blob storage and Azure Event Grid, which can trigger functions based on various event sources. Azure Functions pricing is similar to AWS Lambda. You are charged based on the number of executions, the duration of function execution, and the allocated memory. It's designed to be cost efficient, especially for infrequent or sporadic workloads. Next, we have Google Cloud Functions, another serverless compute service that allows you to run your code in response to events from Google Cloud Services or HTTP requests. It supports multiple languages like Node.js, Python, and Go. Google Cloud Functions are built around function deployments that can be managed through the Cloud Console or CLI. Event sources like cloud publish subscription, publishing subscription, Firestore, or cloud storage can trigger these functions. Additionally, IAM and permissions help ensure that only authorized users and services can invoke these functions. Google Cloud Functions also uses a pay-as-you-go model. You are charged based on the number of invocations, execution time, and the amount of resources your function consumes. This makes it scalable and cost effective for a wide range of use cases. Serverless architecture is ideal for various use cases. You can build web applications by hosting backend functions. It's also great for real-time data processing, such as handling IoT data streams. Additionally, file processing workflows and microservices can be efficiently handled using serverless systems. When designing serverless systems, it's important to consider a few factors. Statelessness means that functions can't rely on in-memory data, so use external storage if necessary. Be mindful of cold starts that can affect latency, and remember the execution time limits of serverless platforms. Finally, plan for scaling and the associated costs, especially when running large-scale applications. To design effective serverless architectures, here are some best practices. Keep your functions small and focused on a single task to ensure efficiency. Optimize for performance to minimize cost, cold starts, and always implement error handling for resilience. Use cloud native tools for logging and monitoring, and make sure your system is secure by leveraging IAM roles and validating inputs. In conclusion, serverless computing offers scalability, cost efficiency, and reduces infrastructure management. AWS Lambda, Azure Functions, and Google Cloud Functions each provide robust serverless solutions with unique features. By understanding the principles and best practices, you can design highly efficient and scalable systems using serverless architectures. That concludes the presentation. Thank you for your attention. If you have any questions or need further clarification, feel free to ask now.